how you go back from a binary number to its decimal representation. And for that, I would like to tell you a story. So this guy Ali said that I have 547 rupees. So how would you say that Ali would be looking at this money? Maybe he has a note of 500, and then maybe he has 40 rupees in tens, and then maybe he has 7 rupees in coins, right? So this part is called the hundreds part. This one is called the tens parts, and this one is called the units part, maybe, or ones. Sometimes they also called ones. So let me write it over here, and let me write this one over here. Okay. So I hope everyone agrees to this, that this is the amount that he will have if he has these things in these formats. And what if I tell you that he could also have 5 notes of 100 each? And no, I have to write it down like this. Yeah. So what if I told you he had 4 notes of 10 each? And what if I told you that he had 7 coins of 1 each, right? So you would say, yes, of course, this is a possibility. It could happen. It actually happens a lot of times. So we're talking about the same number, 547, right? What if I told you that I could write it down as 10 multiplied by 10? And I could write it down as 4 multiplied by 10, and I could write it down as 7 multiplied by 10. Sorry, 1. And what if I change this? What if I told you that I could write this thing as in a very new format, probably new to some and not that new to others? I could write it like that 10 is being multiplied over here 2 times. 10 is being multiplied here for 2 times. And let me place brackets on this thing, because I would like to have this statement applied only to the 10 and not to the 5. So 5 multiplied by what? 10, which is being multiplied 2 times. So I'm going to copy this over here, and I'm also going to copy it over here, and I'm going to write down over here that 10 is being multiplied here how many times? If I talk about this 4 multiplied by 10, how should I modify this statement? This is how I should be modifying this. So here I could see 2 10s, so I had to write 10 is being multiplied 2 times, and here it was 5, so I had to write 5. And similarly 4, you can see 4 over here. Now we had to change 5 to 4, and then we had to look and see that 10 is only visible here only once, so we had to write 10 is being multiplied 1 times. So I copied the same statement over here. So I would be writing what if I wanted to stay with this 10 thing, because I can see 10 over here, I can see 10 over here, I want to see 10 over here. So can I change it to something? What if I said it is only 0? And this is something which is really the reason why I started telling you that I could see 110 over here, and sorry, 2 10s over here. Then we all agreed that we can see 110 over here. Then I hope we can agree that we cannot see any 10 over here, and that would be equivalent to saying that 10 is being multiplied 0 times over here. If you simply follow the pattern, even though it can be very difficult to digest, but this is mathematically correct. We are not saying that we are multiplying 10 by 0. I'm saying that I am multiplying 10 0 times. In other words, I am not multiplying with 10. I could also say that not multiplying with any 10. I could say this, or I could say this, same thing. So power function, what it does is, if I write 10 and I write 2, it is exactly the statement that I have written over here in English, that 10 is being multiplied 2 times, not by 2, not being multiplied by 2, but 2 times, right? I'm writing 10 multiplied by 10. So 2 10s are being multiplied. I want to say in English that 10 is being multiplied 2 times. 10 multiplied by 10. Similarly, here I want to say is 10 is being multiplied only 1 time. So the 10 is being multiplied 1 times. There is only 110. And similarly, here, this is the confusing part. So, but mathematically, let me show you that this is a built-in function of Microsoft Excel, which raises the power of 10 by 2, meaning mathematically it says that 10 is being multiplied with 10. So let's see the result. The answer is what? 100, which we started with, right? So we are happy. This is something we expected, right? So let me copy this formula. Let me write it over here. Here we made a statement that if we are looking at only 110, it means that 10 is being multiplied 1 times. So I write 10 comma 1. Let's see what the result is. The answer is 10. We are happy. We started with a 10 and we are getting a 10. Now let me paste the same formula over here. And now let me write down 0 over here. Let's see what do we get. We get a 1. So I will not back out from my statement that this is difficult to digest. I stand by that statement because definitely this is difficult to digest. But as I said, if you keep in mind that by this statement, what I mean is that there is an absence of a 10 being multiplied. So 1 is a true picture of an absence of a 10. There is no 10 over here. Similarly, let me show you something. What if I write 234 multiplied, raised to the power 0? I'm trying to say 234 is being multiplied 0 times. What would be the answer? 1 again. So that is another way of having a proof of concept that anything raised to the power 0 is 1, right? So we come back to what Ali was saying, and Ali was saying these things. And now let me try to use mathematical representation to, show you these things better. I'm going to write 5 multiplied by 10 raised to the power 2 plus 4 multiplied by 10 raised to the power 1 plus 7 multiplied by 10 raised to the power 0. And that is how we write this 2 I was talking to you guys about in this line. This 2 is being seen over here as the small number on top right corner of a number. So it means that we are saying that 10 is actually being multiplied 2 times here. And if I write 10 to the power 1, I'm trying to say that 10 is being multiplied once over here. If I try to say 10 to the power 0, I'm saying that there is only a 1 and there are no tens. There are 0 tens over there, right? So this is really amazing because now you are able to see the base of your numbering system. Here I can see that I counted this way because I have 10 fingers. I have 10 fingers and I have 10 symbols to represent each number from 0 to 9. And these 10 fingers, allowed me or maybe stopped me from introducing new symbols into my number system. And that's why we call it a decimal system. Therefore, this is a decimal number system. Or if I restate this thing, I can say that this is a base 10 number system. We can actually see the base over here. So let me try to highlight this. So I can see a 10 everywhere. Why? Because I was actually counting in the base 10. I can extend this definition and I can construct as big a number as I want. Like for example, I had let's start with even a smaller number like 3546. I could write it down in the same format. What I would have to do would be that I would simply say that there is a new number here which is being multiplied by 10 to the power 3, and that's it. But 10 would be there. Why? Because I know that the person who told me this number was from this world, from human world, and he was counting in the decimal system. So he had to, by the way, tell me before. And most of the time it is already assumed, as you know, that this is our assumption that the person who is giving me money is counting in base 10. So we write down base 10 like this as a subscript. So once you understand that you can break down a number using this format, you can apply this pattern of thinking to any number system you like. So for example, if I have 12 in decimal, so we said we did the repeated division the last time, and we converted this 12, which was in normal standard decimal format, and we wrote down the binary equivalent, which was 1010, and we said this is the base 2 representation of the number 12 in decimal system. So now I am going to use this explanation and I'm going to write this number using base 2 in this format, and I'm going to give you guys a minute to see if you guys agree and understand what is going on over here. So I am writing 1 star 2 to the power 3 plus 0 star 2 to the power 2 plus 1 star 2 to the power 1 plus 0 star 2 to the power 0. And I say my claim is that this number is actually the same number, which is 1010 in base 2. Okay. So now I'm going to highlight this number 2 with another highlight color, just to give you a similarity, just to have you look at the similarity between this line. And let me complete this line. uh, it should be written like this, and actually if I be complete in this, I should be writing this. Okay, so now I want you guys to compare this line and this line, and tell me if you understand what I'm trying to so we are using the definition of a number using its base. I'm sorry, there should be a star over here. We are representing a number using its base and some mathematics that is able to calculate the value of this number. And we applied the same to this number where the base was different, and we took each number. So this one we see over here, we have taken this one and we have placed this one over here. And we took this second number, which is 0, and we placed it over here. We took this third one and we placed it over here, and then we took this 0 and we placed it over here. And we incremented all the power values starting from 0, 1, then 2, then 3. And similarly we changed the base to whatever the base we were talking about. So right now we were talking about base 2, and instead over here we were talking about base 10. And let me you know I can say that calculate this number. So 2 to the power 3 is, if you calculate 2 multiplied by 2 multiplied by 2, it is equal to 8. 2 2 times 4, 4 2 times 8. So I'm going to write 8 over here. Then 2 to the power 3, this sorry, 2 to the power 2 is 2 multiplied by 2, which is 4. So I would be writing 0 uh, 0 multiplied by 4. Why am I writing it even if I know that it's going to be multiplied by 0? The reason is that I'm just trying to explain to you guys what is happening. Then 1 star 2 to the power 1 is 2. Then I'm going to write 0 star 2 to the power 0 is how much?
1.
1. Exactly. So now I can write it like 8 plus 0 plus 2 plus 0, and the final answer to this is uh, I'm sorry. Oops. Okay. I so here it should be 10, and I was not so I converted wrong in my head. I had to write 1100. Oops. So this example is going to change. So 1100, I'm going to make all the changes, and that would actually help you even understand it slightly more. That 110 is being seen here like 1100, and then it will be 1 over here and 0 over here, and then it would be 4 plus 0, and the answer would be 12. Right? So you can see that we started from the binary number and we reached the decimal equivalent by doing calculation in decimal, because when I did 2 to the power 3 equal to 8, that was being done in decimal thinking style, because 8 only exists in decimal number, 2 only exists in decimal number, as far as now, because we're only talking about decimal and binary. So this method that we have done over here, I can label this as conversion from binary to decimal. Okay.